Welcome to Lecture 9 of Computer Programming Fundamentals, L9 Arrays. The C computer programming language, based on the computer procedural language paradigm, has a major deficiency. C does not include a string data type. To remedy this deficiency, the C computer programming language depends exclusively on arrays. As such, this lecture demonstrates the C computer programming language's extensive use of array processing. So let's take a look at 4 C computer program models that demonstrate array processing. 4 C computer program models are used to demonstrate array processing. Where array processing in the C computer programming language was used initially to provide a workaround for remedying C's lack of a string data type. In this case, a single-dimensional array is provided as a workaround for the string data type. C computer program models L9A.C and L9B.C demonstrate single-dimensional arrays. L9B.C using the char, or character data type array, to emulate a character string. L9A.C using the INT, or integer data type array, to emulate a numerical string. Two-dimensional arrays are demonstrated by C computer program models L9C.C and L9D.C, where L9C.C displays the entire two-dimensional array, and L9D.C displays just one row from the entire two-dimensional array. Let's take a closer look at each C computer program model. Computer program model L9A.C demonstrates a one-dimensional array that provides a workaround for the C computer program language's lack of a string data type. Let's take a closer look at the source code for declaring and processing a string of integers. The first line, /L9A.C dash array of integers, which is a line comment specifying computer program model L9A.C as a program for processing an array of integers. The second line, #include less than stdio.h greater than, which includes the standard input-output function definitions, especially for the printf function call that will be used to display the results. The third line, int main left paren void right paren, defines our main function, which is the cornerstone of every C computer program. Remember, all C computer programs require a main function. A main function where all the C computer program's processing instructions are placed. In this case, the INT data type preceding the keyword main indicates that when the execution of all instructions included in main are completed, an integer will be returned to main. See the last line of the computer program model, return 0, semicolon. The left paren void right paren part of the INT main, left paren void right paren, indicates that the execution of the main function is void or requires no parameters or variables to be passed to the main for the instructions within main to execute properly. Next, note the opening and closing braces that demarcate the program block. That includes all main computer program instructions. Next, the first line after the opening brace, int mynums, left bracket 3 right bracket equal sign left brace, 12, 5, 27 right brace, semicolon, is an assignment statement which declares and assigns values to mynums. The INT preceding the variable minums declares the array minums to contain integers. That is, each element of the array minums is an integer, because all elements of an array must be of the same data type. In this case, all the elements are declared as integers. Next, the left bracket 3 right bracket part declares the array minums as a one-dimensional array containing 3 elements. The equal operator makes the computer program instruction an assignment instruction by assigning 3 integers to the 3 integer elements declared for the array minums. That's the left brace 12, 5, 27 right brace. In this case, the 12 to the first element, 5 to the second element, and 27 to the third element. The next line, INTI semicolon, declares a variable I as an integer. The variable I will be used to index or subscript within the array. For example, the value of minums, left bracket, I, right bracket, where I equals 0 is 12. Note by default, as in most computer programming languages, including the C computer programming language, the first element of an array starts with a subscript value of 0. Okay, now the declarations and assignments of variables included within main scope are complete. So let's take a look at the processing part. For left paren, I equals 0, semicolon, I less than equal 3, semicolon, I plus plus right paren. Left brace, printf, left paren, double quote, %d, \n double quote, comma, minums, left bracket, I, right bracket, semicolon, right brace. This is the computer program code based on a member of the family of repetitive control structures, namely a for loop. For left paren, I equals 0, semicolon, I less than 3, semicolon, I plus plus, right paren. Here, I equals 0 indicates that the value of I will start out as 0 for the first repetition. The second part, I less than 3, indicates that a repetition will be performed while I is less than 3. The third part, I plus plus, where the plus plus post-increment unary operator following the variable I, indicates that after repetition is completed, the variable of I will be incremented by 1. As such, the repetitive computer instruction will be executed 3 times when the value of variable I is 0, 1, and 2. Okay, let's take a look at the repetitive computer program instruction printf, left paren, double quote, %d, \n double quote, comma, minums, left bracket, I, right bracket, right paren, semicolon. The only computer program instruction located between the opening and closing braces, which demarcates the program block containing just this one computer program instruction. Printf is a function call whose function definition was part of the standard input-output header, included in the #include less than equal stdio.h greater than statement. Note the printf function call passes 2 arguments when executed. Double quote %d, \n double quote, and minums, left bracket, I, right bracket, where the first is a format specifier for displaying integers. The \n is an escape character that will display the next result on a new line. The minums, left bracket, I, right bracket part specifies the integer value that will be displayed. In this case, for the first repetition, where the value of I is 0, the value 12 will be displayed. Okay, let's take a look at the actual execution of computer program model L9A.C. Note the values 12, 5, and 27 displayed on separate lines. I trust that computer program model L9A.C demonstrates how the C computer programming language compensates for lacking a string data type. by using a workaround based on a one-dimensional array. A workaround, as we will see later with the transition to the Java computer programming language, is no longer required, as Java is based on the computer programming language's object-oriented paradigm, which contains many object data types, including string data types. Computer Program Model L9B.C also demonstrates a one-dimensional array, but in this case a character array which is more akin to a string data type, because the array contains a string of characters which more closely represents a string data type. Without repeating what has been previously discussed with regard to the numerical one-dimensional array, let's examine the declaration of the one-dimensional character array, namely char, last name, left bracket, 80, right bracket, semicolon. Here the array last name is declared as an 80-element one-dimensional array. This allows the array to hold a maximum of 80 characters. In this example, as you will see, we will not use all 80. Each element of the array will be of a character data type. Note in this case, the array is not assigned values for each element of the array, but rather the printf and scanf function calls combination is used to prompt and then enter the character element values. See computer program instructions, printf, left paren, double quote, please enter last name, /n, double quote, right paren, semicolon, scanf, left paren, double quote, %s, double quote, comma, last name, right paren, semicolon, where the printf function call prompts the user to enter a string of characters for the user's last name. In this case, note I entered my name, Kubli. The scanf function call then scans or assigns what I entered to the one-dimensional array last name, using the format specifier %s, which formats the entry as a string. The last computer program instruction within main, printf, left paren, double quote, last name, is %s, /n, double quote, comma, last name, right paren, semicolon. Here the printf function call merely displays the results. In this case is what I entered, my last name, Kubli. I trust computer program model L9B.C demonstrates how the C computer programming language compensates for not having a string data type by utilizing a one-dimensional character array. Now that we have demonstrated the one-dimensional array, the workaround for the C computer programming language's compensation for lacking a string data type, let's take a look at a two-dimensional array. Given computer program model L9C.C, two-dimensional arrays provide the processing vehicle for processing tables, the primary intention of the array data type. For the case of the two-dimensional array, let's take a look at what has been added. First, two instructions outside of the main function definition are provided to define the rows and columns of the table, namely #define ROW4, #define COL3, where the table will have 4 rows defined by the defined constant ROW, and the table will have 3 columns defined by the defined constant COL. The scope of these defined constants is for the entire computer program model, just like the scope of the function definitions included in stdio. What this means is that when computer program instructions included within main reference to ROW or COL, they are referencing the values 4 and 3 respectively. For example, C computer instructions 4, left paren I equals 0, semicolon, I less than ROW, semicolon, I plus plus, right paren. left brace, 4, left paren, j equals 0, semicolon, j less than COL, semicolon, j plus plus, right paren. Here we have two for loops, the first cycling through the rows with the second for loop nested within the first for loop, allowing the cycling through the columns for each row. As such, while processing the first row, we cycle through the 3 columns in that row, following the same processing for rows 2 through 4. Okay, next let's take a look at the RNUMS array declaration and assignment instruction. Namely, INT RNUMS, left bracket 4, right bracket, left bracket 3, right bracket, equal, left brace, 1, comma, 2, comma, 3, right brace, comma, left brace 4, comma, 5, comma, 6, right brace, comma, a left brace 7, comma, 8, comma, 9, right brace, comma, left brace 10, comma, 11, comma, 12, right brace, semicolon. First of all, the INT part declares all 12 elements of the array RNUMS as integers. Remember, all the elements have to be of the same data type. Next, the RNUMS left bracket 4, right bracket, left bracket 3, right bracket part declares a 2-dimensional array or table containing 4 rows and 3 columns. Next, the equal operator tells us that this is an assignment computer program instruction, where what is on the right side of the equal operator is assigned to the variable on the left side of the equal operator. In this case, left brace, 1, comma, 2, comma, 3, right brace, comma, left brace, 4, comma, 5, comma, 6, right brace, comma, left brace, 7, comma, 8, comma, 9, right brace, comma, left brace, 10, comma, 11, comma, 12, right brace, where the first outer set of right and left braces demarcates the 4x3 RNUMS array, and the second set of right and left braces demarcates each of the 4 rows, where the commas demarcate the 3 columns within each row. Thus, the first row is assigned the element values 1, 2, and 3 for columns 1, 2, and 3, and so on for rows 2 through 4. Next, let's take a look at how we will subscript through the array, namely int I, j, semicolon. Here, integer variable I is used to subscript through the row 4 rows, and integer variable j is used to subscript through the 3 columns. Okay, next let's take a closer look at the 2 for loops. The first or outside for loop subscripts through the 4 rows, namely 4, left paren I equals 0, semicolon, I less than, ROW, semicolon, I plus plus, right paren. Here the I equals 0 part initializes the row subscript I at 0. Next, the I less than row repeats the computer program instructions where ROW is a constant variable equal to 4. Those computer program instructions demarcated by the opening and closing braces. The program block immediately following the outer for loop, namely the 1 computer program instruction 4, left paren, j equals 0, semicolon, j less than COL, semicolon, j plus plus, right paren, for the inside for loop that cycles through the columns. The last part of the outer for loop, I plus plus, includes post-increment unary operator plus plus that increments the subscript variable I after 1 repetition of the outer for loop. Next, let's take a look at the inner for loop, the for loop which is executed for each repetition of the outer for loop. 4, left paren, j equals 0, semicolon, j less than COL, semicolon, j plus plus, right paren. Here the j equals 0 part initializes the subscript variable j to 0, where j is the subscript for indexing through the columns. Next, the j less than COL repeats the computer program instructions, where COL is a constant variable equal to 3. Computer program instructions demarcated by the opening and closing braces, the program block immediately following the inner for loop, namely the one computer program instruction, printf, left paren, double quote, %d, double quote, comma, rnums, left bracket, I, right bracket, left bracket, j, right bracket, right paren, semicolon. Here the printf function call displays each element of the rnums array based on subscript variables of I and j, where the I subscript designates the row and the j subscript designates the column. The %d is the format specifier for formatting the array element as an integer. Note that there is no /n escape character for a new line included within the first argument of the printf function call. As such, the display of all 12 elements of the array displays on a single line. I trust that computer program model L9C.C demonstrates the two-dimensional array or table. Computer program model L9D.C processes the same two-dimensional array as computer program model L9C.C, but displays the table differently. Here, L9D.C displays the table row by row for each of the 4 rows, whereas computer program model L9C.C displays the entire table as one line of 12 array elements. As such, I will only discuss the computer program instructions of computer program model L9D.C that display the table row by row. Namely, if left paren j equal to right paren, printf left paren double quote %d /n double quote comma rnums left bracket I right bracket left bracket j right bracket right paren semicolon else printf left paren double quote %d double quote comma rnums left bracket I right bracket left bracket j right bracket right paren semicolon. Here we have the if-else control structure, a member of the family of decision control structures where there are just 2 choices for the decision. In this case, if the j column subscript is equal to 2, then display the 3rd column element for the array and then go to a new line. Remember, since array subscripts default to start at 0, a subscript value of 2 really refers to the 3rd column. Thus, the computer program instruction printf left paren double quote %d /n double quote comma rnums left bracket I right bracket left bracket j right bracket right paren semicolon. Note the /n escape character, which creates a carriage return in the line feed on the display, causing the next row of the table to be displayed on a new line. If the j column subscript is not equal to 2, the second choice or else part. For the else, the array element is displayed without the creation of a new line for the display of the beginning of the next row. Thus, the computer program instruction printf left paren double quote %d double quote comma rnums left bracket I right bracket left bracket j right bracket right paren semicolon, which was the only instruction within the inner for loop for the computer program model L9C.C. I trust this demonstrates the subtle differences between computer program models L9C.C and L9D.D, namely how the two-dimensional array or table is displayed.